sodium, carbon, nitrogen and sulfur. If it is present both of the things, it will form blood red color. The percentage of each element present in the given organic compound will be called as quantitative analysis. Whatever the small amount of filtrate, that is the third part of sodium fusion extract, filtrate is there, it will be treated with dilute HNO3 and the formation of white precipitate will form. What is that white precipitate is containing? That is nothing but silver chloride. Hello everyone, this is Harshita Bhavasar from Vidhyaashram School of Excellence. Today we are starting up session 7 from the chapter Organic Chemistry, some basic principles and techniques. In the last class, we have discussed about the purification methods, that is methods of purification of organic compounds. In that, distillation, sublimation, crystallization, differential extraction and chromatography. These are the 5 major techniques we will use for the purification of organic compound after the synthesis. So, in this session, we will discuss about the qualitative analysis of organic compound and quantitative analysis. Okay. First, we will see the qualitative analysis of organic compound. So, before that qualitative and quantitative analysis, you have to understand what are the both terms. Qualitative analysis means what are the constituents are present in the given compound and what is the property we will understand. In the quantitative analysis means after the synthesis, how much of each element is present in overall compound will be determined. So, this is the major difference between the qualitative analysis and quantitative analysis. In the qualitative analysis, which are the elements are present we will find out. In the quantitative analysis, the elements which are present, how much quantity or how much amount is present in that compound we will analyze. So, we will see in detail now. See here, composition of compound refers to the various elements present and their ratio. Whatever the composition or whatever the elements are present in the compound, it will be various or it will be vary and in their ratio. The elements are detected by qualitative analysis and amounts are estimated by quantitative analysis. That's what I told now. The overall elements are detected by quality and the amounts are estimated by quantitative analysis. Once an organic compound is isolated from a suitable source and then purified, the next step is to detect the elements present in it. This is followed by the determination of relative proportion of the elements by quantitative analysis for the calculation of its empirical formula. See, once again I am explaining. Overall, purified or each and every step has been done. Later, we have to analyze what are the elements present in that compound. That process we will be called as detection of elements. For the detection of elements, for individual element, there is an individual process to find out that element or to confirm that element is present in that compound. For that process, we will call it as detection of elements. Okay, this is followed by determination of relative proportion of the elements. Okay. Next is detection of element. First one, detection of carbon and hydrogen by copper oxide test. By using copper oxide, we will determine or we will detect carbon and hydrogen is present or not. The organic compound is mixed with dry cupric oxide. The mixture is strongly heated in a hard glass tube fitted with a cork and a delivery tube. The liberated gases are passed into lime water. Carbon present in the compound is oxidized by cupric oxide to carbon dioxide, which turns lime water milky. Okay, whatever the organic compound has been synthesized or purified, that should be mixed with dry cupric oxide and it will be heated in a test tube. Whatever the compound should be taken in a test tube itself, that should be heated with a cork and it will liberate some of the gases. So that liberated gases should be passed into another test tube which is containing the lime water. So carbon present in the compound is get oxidized by forming carbon dioxide. What is oxidation? The addition of oxygen molecule, right? So that oxidation takes place, carbon dioxide will form, and the lime water whatever we are taking in another test tube, it will turns milky. Okay, means that milky nature will form in that test tube. The hydrogen present in the compound is converted into water, which appears as droplet at the cooler part of the test tube. That's what we saw in that carbon. Now the hydrogen present in the compound is converted into water, which appears as droplets at the cooler. Okay. Test tube with anhydrous copper sulfate, which turns blue. If you want to see in the confirmatory part way, the tested test tube already, another test tube with having anhydrous copper sulfate, the droplets if you put into that test tube, it will turns blue. Understand? See here, carbon, which is that organic compound treated with cupric oxide, it turns with copper and carbon dioxide getting oxidized, and here calcium hydroxide with that carbon dioxide whatever it is there, and it will form calcium carbonate, it is milky in nature. And this is hydrogen treated with cupric oxide, copper and water. And if we treat it with cupric sulfate, it turns to water and it will give blue color. That's what they have told. If we treat it with copper sulfate, it turns blue. That is how the carbon and hydrogen will be detected. Next is qualitative analysis of organic compound. Same thing, in that detection of nitrogen, halogen and sulfur. You know about nitrogen, sulfur. What is halogen? That group 17, it may be chlorine, it may be iodine, it may be bromine or fluorine, right? Before that detection, you have to do the Lessagnese test, that is nothing but sodium fusion extract. Okay, what is that Lessagnese test? It is a preparation of sodium fusion extract. How you have to do the sodium fusion extract means, a piece of dry sodium you have to take it in a dry fusion tube, okay, and that should be heated in a burner. After that getting little bit melted, you have to add your organic compound into that, and later you have to heat that again for the red hot plunged heat. Okay, then another side you have to take mortar with some water. Whatever you have heated that fusion tube, you have to put into that. Okay, and you have to make a complete paste. Make it in a 3-part for the usage of nitrogen, halogen and sulfur, or the any detection of elements. Okay, now we will see here. A piece of dry sodium is introduced into fusion tube. Fusion tube will be very small, not like a complete test tube, and heated it till it melts. What? That sodium should get melted within that fusion tube. A drop of few crystals of organic compound is added to the fusion tube. After that getting heat or melt, little bit of organic compound you should add into that fusion tube. The mixture is fused gently on a Bunsen flame initially. The tube is then heated to red hot and plunged into distilled water taken in a mortar. You know that mortar and pestle, within that mortar little bit of distilled water should be there. After getting that complete heat of fusion tube with organic compound and dry sodium, you have to put into that mortar. The contents on ground thoroughly and filtered. After that complete grinding, it should be filtered. The filtrate is divided into 3 parts. When the organic compound is fused with sodium, nitrogen and halogen, okay, the converted into sodium cyanide, sodium halide and sodium sulfide respectively. Okay, when it is, the organic compound is completely mixed with that, when you do the test, it will give sodium cyanide, sodium halide and sodium sulfide respectively. Okay, this is about the Lessagnese test or preparation of sodium fusion extract. Next, in that first test for nitrogen, a few crystals of ferrous sulfate are added to a small amount of the filtrate. Whatever you have taken the filtrate from the sodium fusion extract, for that filtrate you have done the 3 parts. Within that first part you have to take, for that ferrous sulfate you have to add. The mixture is boiled and cooled. It is acidified with hydrochloric acid and few drops of ferric chloride solution are added. Sodium cyanide in the filtrate reacts with ferrous sulfate to give sodium ferrocyanide. It further reacts with ferric chloride to give a blue colored solution of ferriferrocyanide. What they are telling? First ferrous sulfate are added to the small amount. What it will form? First one, you have to add HCl, you have to acidify it with that, and ferric chloride will form. After that ferric chloride, sodium ferrocyanide should form with that. This is cyanide, this is iron. Okay, this is ferrous cyanide, right? And this is a complex whatever here. Again you are treating with ferrous here, and it will form ferriferrocyanide, that is in Prussian blue color. Okay. Next one is test for sulfur. A small amount of the filtrate is treated with excess of acetic acid and lead acetate solution. The second part of the sodium fusion extract is used for the detection of sulfur. For that sulfur, lead acetate and the excess of acetic acid is used. See here, sulfur and lead getting to react here. It will form PBS, lead sulfide will form. It is a black precipitate. To a small amount of sodium fusion extract, sodium nitroprusside solution is added. Appearance of color confirms the presence of sulfur. Whatever the sodium fusion extract is there, for that you can add sodium nitroprusside also. It will give violet color. It will also exhibit, or it will also show that sulfur is present in that organic compound. It will be in a violet color. If the given organic compound contains both nitrogen and sulfur, then the extract gives blood red color with ferric chloride due to the formation of ferric thiocyanide. There is a chances of containing nitrogen and sulfur at a time. That time it will form blood red color, forming sodium or ferric thiocyanide will form. Okay. See here, sodium, carbon, nitrogen and sulfur. If it is present both of the things, it will form blood red color. Next is test for halogens. A small amount of the filtrate is treated with dilute HNO3 followed by silver nitrate solution. Formation of white precipitate of silver chloride soluble in ammonium hydroxide indicates the presence of chlorine. Whatever the small amount of filtrate, that is the third part of sodium fusion extract, filtrate is there, it will be treated with dilute HNO3 and the formation of white precipitate will form. What is that white precipitate is containing? That is nothing but silver chloride. Okay, then it will be soluble in ammonium hydroxide and indicates the presence of chlorine. See here, sodium chloride and this is AgNO3, silver nitrate. It will form sodium nitrate and AgCl, that is white precipitate of sodium chloride. On the other hand, formation of a pale yellow precipitate, that is silver bromide, which is sparingly soluble in excess of ammonium hydroxide, indicates the presence of bromine. And another formation of deep yellow, this is pale yellow, bromine is present. If it is deep yellow, iodine is present, that is silver iodide is present. Okay. Next is detection of phosphorus. A small amount of extract on heating with the sodium peroxide gives sodium phosphate. This on boiling with nitric acid followed by the addition of ammonium molybdate gives a yellow color or precipitate of ammonium phosphomolybdate. This confirms the presence of phosphorus. Whatever the extract is present, on heating that one, sodium peroxide if we add with, it will give sodium phosphate. Boiling with same sodium phosphate, if you add nitric acid, it will give ammonium molybdate with a yellow color or yellow precipitate of ammonium phosphomolybdate. And that yellow color or yellow precipitate, it will confirms the presence of phosphorus. Okay, this is ammonium molybdate and it will form ammonium phosphomolybdate, which is in a deep or yellow precipitate. Till now, we have seen the qualitative analysis of the organic compound, right? The detection of halogens or nitrogen, sulfur, phosphorus, anything. Now, we are seeing the quantitative analysis. What is that quantitative analysis? The determination of the percentage composition of various elements present in the compound is known as a quantitative analysis. The percentage of each element present in the given organic compound will be called as quantitative analysis. Estimation of carbon and hydrogen. We have seen in the qualitative analysis the carbon and hydrogen. Now the estimation of carbon and hydrogen we are seeing by Liebig's method. So what is the principle of this estimation? Means a known mass of organic compound is heated in the presence of pure oxygen. Carbon dioxide and water formed are collected and weighed. The percentage of carbon and hydrogen in the compound are calculated from the masses of carbon dioxide and water. A known mass of organic compound we have taken and that will be heated in the presence of pure oxygen. Okay, and the carbon dioxide and water are formed, are collected and weighed. The percentage of carbon and hydrogen in the compound are calculated. See here, pure oxygen is given and this is the overall combustion tube and here compound is getting to heat. Okay, whatever the carbon dioxide and water has been formed, that will be collected and weighed. The percentage of carbon and hydrogen in the compound are calculated from the mass of carbon dioxide and water. Here it will form the carbon dioxide and water, right? By that two products, they will identify how much carbon present and how much hydrogen has been present in that compound. This is excess of O2 will be out. Now we will see the procedure. The sample of an organic compound is weighed accurately. It is placed in a porcelain board in the combustion tube. Dry cupric oxide is placed next to the porcelain board for the complete oxidation of the compound. See here, they have taken a platinum board. In that sample has been taken, that is a complete combustion tube. Next to that, copper oxide pellets are present for the oxidation. Two absorption U-tubes containing anhydrous calcium chloride or anhydride and the concentrated solution of potassium hydroxide respectively are weighed and connected to the combustion tube as shown in the figure. Next to that copper oxide, two U-tubes are present. One is containing anhydrous calcium chloride, another one is containing concentrated potassium hydroxide solution is present. The combustion tube is heated. Pure and dry oxygen is passed into the combustion tube. Water and carbon dioxide formed are led to the absorption tubes and weighed. The increase in the mass of the absorption tubes gives the mass of carbon dioxide and water. See here, pure and dry oxygen has been passed here and this absorption tubes absorb completely the carbon dioxide and water, whatever it has been formed inside the combustion tube. If the masses of these U-tubes are getting increased, then it is understood the carbon dioxide and water molecule has been producing inside that absorption tube and it will be used for the estimation of carbon and hydrogen by those two products. See here, this is the equation carbon and hydrogen. This is X means carbon, Y means hydrogen of that overall composition by 4. This is oxygen. Carbon dioxide will form here, water will form. Next, calculations. Mass of organic compound will be X gram. This is the mass of carbon dioxide formed is A gram. This 44 gram of carbon dioxide means CO2. The overall molecular weight of carbon dioxide is 44 gram containing 12 gram of carbon. And A gram of the compound contains 12 by 44 into A gram of carbon will be Y gram. This is containing 12 by 44 and this is the carbon present. Here x gram of the compound contain y gram of carbon and 100 gram of compound contains y by x into 100 gram of carbon. Overall, how much of hydrogen and carbon is present for the 100 gram of compound containing? Therefore, percentage of carbon in the compound is mass of carbon dioxide formed by mass of organic compound into 12 by 44 into 100. This carbon dioxide we got from the combustion tube, and this is overall mass of organic compound. 12 is that AMU value. This is molecular weight of 44 into 100 because we are seeing the percentage. This is water formed, that's why B gram. 18 gram of water contains 2 gram of hydrogen because H2O, overall water, right? The molecular weight of water is 18 gram and that's 2 by 18 into B, that is Z gram. Okay, 100 gram of compound contain Z by X into 100 of hydrogen. The overall percentage, mass of water formed by mass of organic compound into 2 by 18 into 100. The amount of water divided by the overall organic compound, mass of organic compound, that's why 2 by 18 into 100. We'll see one of the problem now. 0.1 gram of organic compound containing only carbon and hydrogen on combustion gave 0.275 of carbon dioxide and 0.225 gram of water. Calculate the percentage of carbon and hydrogen present in the compound. See, mass of organic compound 0.1 gram. Mass of carbon dioxide 0.275 gram. What we have to calculate? The percentage of carbon and hydrogen from the compound. The percentage of carbon, how we will calculate? Mass of carbon dioxide by mass of organic compound into 12 by 44 into 100. This is the standard formula. What they have given? 0.275 of carbon dioxide mass. This is 0.1 mass of organic compound. This is, we will get by equation. The overall is 75%. Next is mass of water they have given. Just you have to identify the percentage of hydrogen, mass of water formed and mass of organic compound into 2 by 18 into 100. This is a standard equation. You have to amplify that whatever the numericals or whatever the data they have given into the given equation, you will get 25%. The overall percentage will be 75% and 25% you will get in that 100% of carbon dioxide and water molecule you will get in the Liebig's method. In the next class, we will study about the quantitative analysis will be continued. In that, estimation of nitrogen, estimation of halogen, sulfur and phosphorus will be seen. As of now, you have seen the estimation of carbon and hydrogen. In the next session, you will study about nitrogen, phosphorus, halogen and sulfur. I hope you have understood completely what I have taught today. So, we'll meet in the next session. Thank you.